right, this is part 3 of Unit 6 regarding moles, percent composition, and empirical and molecular formulas. This is the empirical and molecular formula part of it. It is the last part of this unit. So this is just some basic information about the two, so you might want to just take a little bit of time to read through it. So, an empirical formula, just definitional information. This will be used possibly in your multiple choice. Okay, an empirical formula is the formula that represents the smallest whole number ratio of the various types of atoms in a compound. So I would tell you the thing you really need to understand is it's the smallest whole number ratio of a compound that exists. Okay, that is your empirical formula. So how do we find the empirical formula? What you're going to do is if you're given, you're going to take a mass value of each element in the compound. And sometimes they're going to give it to you in percentage format. So if they give it to you in percentage format, you're going to change that percent to its mass value. Then you're going to convert each of those from masses to moles. Okay? And then once you get the number of moles for each element, you're going to divide it by the smallest number of moles in that compound. Okay, so whichever atom has the smallest amount of moles, you divide all the rest of them by that amount, so that that one becomes a value of 1. Okay, sometimes when you do this division, your ratio might end up as a 0.5. If it does, then you're going to have to multiply all the ratios by 2. And sometimes if it ends up as a 0.33 or 0.67, you're going to have to multiply all of them by 3. Okay, but we'll talk a little bit about that. But primarily, those are going to become your subscripts on your compound. On each element of the compound. And so if that's the case, then remember those have to be whole numbers. And so that's really the whole point of making sure that they are whole. Now we have a catchy little poem that you should write down so that you could actually remember this. And that is percent to mass, mass to mole, divide by small, multiply to whole. Okay, so I highly recommend that you write it down and that you say it multiple times, because this is the way to solve for empirical formulas. You change percentages you're given to mass, you take those masses and convert them to moles, then you take those mole values and divide it by the smallest amount, and then you multiply them until they're all whole numbers. Okay, again, percent to mass, mass to mole, divide by small, multiply by whole. Okay, multiply to whole. Again, one more time, percent to mass, mass to mole, divide by small, multiply to whole. Okay? It's kind of catchy. All right, so find the empirical formula for the compound with the percent composition of 26.7% phosphorus, 12.1% nitrogen, and 61.2% chlorine. Okay, if that's the case, we're going to change all those percentages to mass, like our first statement says. So we're just going to say percent, that percent sign becomes a gram sign. So 26.7 grams of phosphorus, 12.1 grams of nitrogen, and 61.2 grams of chlorine. Then we're going to change those masses to moles. To do that, you're going to look up the gram atomic masses off the periodic table. So for phosphorus, we know that there are 31.0 grams for every 1 mole. So when you do that dimensional analysis, you would find out that there's 0.861 moles of phosphorus. For nitrogen, we know that the gram atomic mass off the periodic table would be 14 grams for every 1 mole. So when we do that dimensional analysis, we end up with 0.864 moles of nitrogen. And then for chlorine, we know chlorine's atomic mass is 35.5 grams from the periodic table for every 1 mole. And so when we do the dimensional analysis, we come up with 1.72 moles of chlorine. So we divide by the smallest amount, which is 0.861. So we've taken the mass and changed it to mass, or we've taken the percentage and changed it to mass. We've taken the mass and changed it to moles. Now we need to divide by the small. Okay, so 0.861 is the small, so we divide everything by that, and we end up with 1, 1, and 2. So when we write our empirical formula, the empirical formula for this is going to be PnCl2. Okay, so that 2 becomes, again, the subscript for that compound. All right. So again, and I'll write it because I don't want to move my little box because then that messes things up most of the time. So it would be written like that. So the subscript on the P would be 1, the subscript on the N would be 1, which we don't write ones, and then the subscript on the chlorine would be a 2. All right. Now, molecular formula is a formula for a molecular compound, but really the part of it that you need for this is that it's a multiple of just the empirical formula. All right, so really we can say that the molecular formula equals the empirical formula multiplying its subscript by some value, which is our N value in this formula. How do I find that N value? Well, let me tell you. You do N equals the molar mass of the whole compound, which is typically given to you, okay, in the question, and then you divide it by the empirical molar mass. So you do the empirical formula as GFM, and that would be your denominator, and you would have your GFM of the whole compound on the top. So it would be the whole divided by the part to come up with some ratio number, and this is normally some whole number, okay? So let's talk just a little bit more about molecular formulas and empirical formulas and how they're multiples. If I say that ethylene has the molecular formula of C2H4, 2 and 4 are both multiples of something. They're both a multiple of 2, okay? So if I asked you what the empirical formula was, then the empirical formula would be taking those values and dividing both of them by 2, which that in its simplest form would be CH2. So really what I did is I had the empirical formula and it was multiplied by 2, and that created my ethylene. Okay, so that's how a molecular formula is a multiple of an empirical formula. All right, so to find the molecular formula, what we need to do is we would use our empirical formula, and we might have to find that empirical formula first. So we would use our little percent to mass and mass to mole, divide by small, and multiply by till whole. And then we would divide the molar mass of the empirical, or the molar mass of the compound, by the empirical molar mass. This would give us that whole number value, and then we would multiply the empirical formula's subscripts by that ratio to get the molecular formula. So I have an empirical formula of P2O5. Okay, this is a common drying agent. It's diphosphorus pentaoxide. Okay, but the molecule has a molar mass, so of 283.88 grams per mole. Okay, so that's really my molecular mass. So I want to find the molecular formula of this compound. So the first thing I have to do is find the empirical formula. Well, guess what? That was given to me. So then the thing I need to do is find the GFM of that empirical formula, or the molar mass of it. So if I'm going to calculate the molar mass, it's phosphorus and oxygen, and so I have 2 phosphorus and 5 oxygens. So phosphorus is 31.0 grams, oxygen is 16.0 grams, and so when I multiply them, I get 62.0 grams for phosphorus and 80.0 grams for oxygen. If I add those two together, I would get my GFM, or my molar mass, of P2O5 to be 142.0 grams per mole. Okay, now that I have that, I have to find my ratio that I need to multiply my subscripts by. So I'm going to take my molar mass of my compound, which is my 283.88 grams per mole, and divide it by my empirical molar mass, which is 142 grams per mole. And when I do that, I get a value of 2. So what that means I'm going to do is I'm going to take my P2O5 and multiply it by 2. So 2 times 2 is going to give me 4, and 2 times 5 is going to give me 10. So my molecular formula would be P4O10. All right, here's another example. I have a small sample of hydrazine, and there are 56 grams of nitrogen and 8 grams of hydrogen. The molar mass of this molecule is 32 grams per mole. I want to know the empirical and molecular formulas. So a percent to mass. Well, I don't have percentages. I automatically have masses. So now I want to do mass to moles. So I have 56 grams of nitrogen and 8 grams of hydrogen. I know that there are 14 grams for every 1 mole of nitrogen, which when I do my dimensional analysis would give me 4 moles of nitrogen. I know that there's 1 gram of hydrogen for every 1 mole of hydrogen. So that would give me 8 moles of hydrogen. Then, since I've changed my mass to mole, now I need to divide by small. The smallest value here of moles is my 4. So I'm going to divide both of these by 4. So that would end up with 1 as my subscript for nitrogen and 2 as my subscript for hydrogen. So I would have an empirical formula of NH2. So that answers my first question of this. Now my next question is the molecular formula. So first thing, in order to find that, I have to do my molar mass of my compound divided by the empirical molar mass. So I have to calculate the empirical molar mass. So I have N and H, and I had 1 N and 2 H's. Multiplied my N times 14.0 grams and my H by 1.0 grams. So I would get 14 and 2, and when I add those together, I get 16.0 grams per mole for the empirical molar mass. So then I'm going to do my molecular mass, which was given to me in the question just a minute ago of 32 grams, divided by my 16 grams, which will give me a ratio of 2. So I'll need to take my NH2, which was my empirical formula, and multiply it by that ratio of 2 that I just found. So that ratio would make this into H4. All right. Hopefully that helps. That concludes this part of the notes as well as all the Unit 6 notes. If you have questions, please feel free to ask.